Okay, let's talk about solving these linear equations when you have pronumerals on both sides. It's actually very difficult to do when there's pronumerals on both sides. What you want to do is you want to make it simpler by removing the pronumeral from one of the sides that you're dealing with. It's best to see some examples of how we work with these. So just remember that we only want to have one unknown. Okay, so when we have something like this, 5y is equal to 3y plus 3, we actually have two unknowns. We have the same unknown, but it's in two instances, and that's difficult to work with. So we want to shift one of those. Now, it's actually irrelevant as to which one of these unknowns you shift. It will work out the same way either way that you work. I think it's easier sometimes, though, to shift one side rather than the other. In this instance, it's easier to shift the 3y. Simply because then we're not left with nothing over this other side here. So let's shift this one. We'll shift this 3y one. Okay, so we will end up taking 3y from both sides. Okay, we're going to end up with 2y is equal to 3. To get y by itself, ask ourselves the question, well, it's being multiplied by 2. So what do? That's the reciprocal of that. It's divide by 2 on both sides. And we'll get that y is equal to 1.5. Let me show you really quickly, I wasn't planning on this, but what happens if you remove the other side? Because you can do it. Alright, so let's see, we're going to shift this. So we'll take 5y and we'll take 5y, and this is going to equal 0, and this will equal negative 2y plus 3. Well, I want to shift the plus 3. I'm going to end up with negative 3 is equal to negative 2y. I'm then going to divide this side by negative 2 and this side by negative 2, and I'm going to end up with 1.5 is equal to y. So I got to the same answer, and it works out the same, but this second way, this way was much more tricky because I've ended up with negative numbers that I've had to shift around and make sure I got rid of for my final answer. It's just, this way was easier, much easier. So think before you move, which is the easier way of working, okay? It's important to think about that, just to save you some time. Okay, so let's move on to another example. Now, in this example, I chose to do this the more difficult way to show you, I'll show you something. All right, so we've got 2 outside of x plus 3 is equal to 4 outside of x plus 7. Okay, so firstly, we've got brackets, linear equations with brackets. We can look for factors before we even get started, and we do have some here. We can divide 2 out of both sides here, which we'll do, and we'll end up with x plus 3 is equal to 2 outside of x plus 7 in brackets. Okay, so we can multiply out the bracket here on the right-hand side. We'll end up with x plus 3 is equal to 2x plus 14. It would be easier, much easier actually, to shift this x, but I'm not going to. I'm going to shift this one, the trickier one, just to show you what happens when we get there. Okay, so I'm going to shift the minus 2x from both sides. Okay, I'm going to end up with negative x plus 3 is equal to 14. While my unknown is still not by itself, it's got a plus 3 happening there. I need to take 3 from both sides. I'm going to end up with negative x is equal to 11. And now you might be tempted to say, well, I found my value for my unknown. But if you'll recall, I said it's quite annoying and tricky to deal with a negative variable, negative x. Just as an aside, really quickly, I want you to just think about this. If I've got the number 6, what can I multiply it by to get an answer of 6? What could this be? Well, the only number that fits is 1. So 6 times 1 is equal to 6. So what can I multiply x by to give me x? Well, it would, again, just be 1. But what am I multiplying x by to give me a negative x? Well, it would be a negative 1. So even though we don't see it right here, there is a negative 1. It really is negative 1 times x. So if you want to be pedantic and say, well, there's still something happening to the x that I need to deal with, well, it's being multiplied by negative 1. So what's our options here? Well, we could divide it by -1. -1 divided by -1 equals 1. Or we could multiply it by -1, because -1 times -1 equals 1. So we could do either. I think the multiply is easier. So we're going to do that. We're going to multiply both sides by -1. Once we've multiplied both sides by -1, we have x as being equal to -11. And we are satisfying our variable being not a negative anymore, so that's great. Now, something I haven't talked about much with these linear equations is the checking of your work, but you do need to check your work, okay? Here's how you do it. You will look at the value that you have for x being equal to -11, and you'll substitute that back into your first equation. Okay, so you consider both your left-hand side and your right-hand side. So here was my left-hand side, 2 outside of x plus 3, my right-hand side, 4 outside of x plus 7, and then you substitute in the value of -11 into both of your left-hand side and your right-hand side. Now, the left-hand side works out as -11 plus 3 is -8. -8 times 2 will be -16. Okay, which we have just here. Then the right-hand side, well, we've got 4 being multiplied by -4, which will give us -16. And then you can actually write the left-hand side equals the right-hand side. And because the left-hand side is equal to the right-hand side, we can say, therefore, x is equal to -11. Okay, so it's important to actually prove that you are correct. I don't normally do the proofs when I'm teaching you how to do these things, simply because it's more time-consuming to prove that what I'm teaching you is correct when I know it is. But for you, when you're working, you really need to do the proof to check your work. I can't stress that enough. It's important that you do that.